Usually when we talk about a digital photograph, there's this underlying expectation of permanence.
Right, yeah, like it's locked in.
Exactly. You snap the shutter, the moment is frozen, and that arrangement of pixels just sits there on your hard drive. It's completely static. Trapped in time, basically.
A digital fossil. I mean, the entire appeal of photography, traditionally anyway, is that it captures a definitive, unmoving truth about a specific fraction of a second.
Yeah.
You aren't really meant to negotiate with a photograph once it's taken.
But then you step into the world of creative coding, right? Command line automation, AI integration, and suddenly that fossil starts to, well, to thaw out.
Oh, big time.
Today, we are looking at a project that completely shatters that idea of permanence. We're doing a deep dive into the Kleynenberg perspective.
Which is such a fascinating case study.
It really is. We've got our hands on all the raw project files. I mean, everything.
Yep.
Bash scripts, make files, terminal logs, and some rather panicked notes regarding a YouTube copyright claim.
Oh, yeah, we definitely need to talk about that part later.
Oh, we will. It all details this journey of a developer named Steven Kleynenberg. Driven by this sort of quiet obsession, he took an iconic, static Apple wallpaper and just brute forced it into a living, breathing, 4K, 60 frames per second cinematic experience.
And the craziest part, he pulled this off without ever opening a standard video editor.
Wait, really? None?
Zero. He used pure command line automation alongside Google Gemini acting as his co-pilot.
That is wild. And for you listening, if you want to understand the bleeding edge of AI workflow integration, this is a masterclass.
Absolutely, because it isn't just about making a pretty background, you know?
It's so much more than that.
It's about bridging the gap between raw static data and complex fluid motion. It's a blueprint for taking rigid tools like things designed for server administration and bending them toward a purely creative vision.
Okay, let's unpack this. Our story actually begins with a very specific kind of aesthetic envy, doesn't it?
It does, yeah. We are talking about macOS Catalina,
Yeah.
specifically version 10.15, which introduced this feature called the dynamic desktop.
I remember when that came out. It was such a subtle shift, but it
Yeah.
felt huge.
It's a brilliant piece of user interface design. Rather than a static wallpaper, the operating system subtly shifts the lighting and the color palette of your background based on your local time of day.
So you log in at 7 a.m., the image reflects the sunrise.
Exactly. And by noon, the shadows are harsh, the scene is super brightly lit. At midnight, it's bathed in starlight.
It grounds the digital environment in your physical reality.
It does. And the default image for Catalina is, objectively speaking, just stunning.
Oh, it's gorgeous. It's a solitary, rugged island peninsula surrounded by vast, deep ocean water. Jagged rocks at the tip, breaking the waves, rising up into this beautiful mountainous terrain.
Yeah, it's the kind of image you stare at to deliberately lower your blood pressure between stressful emails.
Totally. And Steven found the ultimate source file powering this feature hidden deep within the macOS file system.
Right, specifically at System Library Desktop Pictures Catalina.heic.
Only one problem, though. Steven is a Linux user.
Yeah, that's a pretty big hurdle.
Right. He operates in a completely different open source ecosystem. But he sees this shifting, mesmerizing Apple experience and gets this itch. He doesn't want his Linux machine to miss out.
Which is such a classic hacker mindset. It's not just about wanting a nice picture. It's about looking at a closed proprietary system and saying, I want that, and I'm going to rip it out of its walled garden and rebuild it on my own turf.
It's so true. Because workspace aesthetics are deeply psychological for developers, aren't they?
Oh, 100%. Your terminal, your window manager, your background, they aren't just decorative. They are the environment where you do your deep cognitive work.
Modifying that environment is a way of asserting control over your tools.
Exactly. Steven's drive to extract that specific Catalina experience and port it to Linux is fundamentally about digital autonomy.
It's like finding the raw, secret ingredients to a Michelin-starred dish locked in a pantry and deciding you're going to reverse engineer the recipe in your own garage using hand tools.
That is a perfect analogy. So he digs into this .heic file.
Right. Now, I know HEIC stands for High Efficiency Image Container, but what makes it different from just a standard JPEG?
The keyword there is container.
Okay.
A JPEG is a single flat image. An HEIC file can act more like a folder disguised as a single file. Apple used this format to package multiple images together, along with metadata that tells the operating system exactly when to display them.
So Steven unpacks this Catalina HEIC and discovers it's not just one picture.
Right. It's actually holding 8 distinct anchor images.
8 specific photos covering different times of the day And in his workspace, he gave them these very descriptive Dutch file names,
They
right?
did, yeah. Like tide01knot.jpg for the night, tide03 optionsonsopcomps.jpg for the morning sunrise.
I am definitely not going to try to pronounce that.
Probably for the best, but it goes all the way to sunset. So if I'm Steven, I've got my 8 pictures. The obvious first step is just to set up a cron job to rotate them, right?
Yeah, that was his exact first iteration. For those writing scripts, a cron job is like the most rudimentary, reliable way to automate tasks.
It just runs things on a schedule.
Exactly. So he wrote a script that checked the system clock and simply swapped the desktop wallpaper to the closest matching anchor image based on the hour.
Mission accomplished. He got the Michelin dish into the garage. It changes based on the time.
But this is where that quiet obsession really takes the wheel.
Yeah.
Because good enough is rarely acceptable to a creative engineer.
No, it really isn't.
A wallpaper that abruptly snaps from sunrise to noon at 9 a.m. isn't immersive. It's jarring.
It breaks the illusion completely.
Right. He wanted to capture the seamless, fluid passage of a whole day.
He needed to transition from a simple slideshow to a 24-hour continuous loop. But the mathematical reality is pretty stark here.
Because he only has 8 images.
Exactly. He has 8 anchor images, but he needs 24 hours of unique hourly video snapshots.
Which raises the question, how do you stretch 8 photos into 24 distinct hours? You can't just invent lighting that Apple never photographed. Or, wait, can you?
You actually can, through mathematical interpolation.
Okay, you're going to have to explain that.
So, Steven wrote a bash script named generate24.esh, and he built a 3-hour step logic into it.
Because 24 hours divided by 8 anchors equals 3.
Spot on. So every 3 hours, he has a perfectly accurate real photo at 00.003.00006.000. He uses the exact anchor image from Apple.
And he labeled these internally as X-Day photo, which means real photo, right?
Yes, but the problem is what happens at 1 a.m.
Right, because Apple didn't provide a photo for 1 a.m.
Exactly. So to fill the gap, Steven leveraged Image Magic, which is this incredibly powerful command line image manipulation tool.
I've used that for basic resizing, but it does way more.
Oh, it's a beast. At 1 a.m., the script takes the midnight image, let's call it image A, and the 3 a.m. image B. It runs a composite blend command.
Okay, so it's mashing them together.
Yeah, it instructs Image Magic to blend 67% of the midnight anchor with 33% of the 3 a.m. anchor.
Okay, I have to stop you there. Because my instinct as someone who uses Photoshop is that a 68733 crossfade between 2 completely different lighting setups would look terrible.
You'd think so, wouldn't you?
Yeah. If you just overlay a bright sunrise over a dark, starry night, you don't get a realistic pre-dawn. You get a blurry, double-exposed mess.
Like 2 distinct shadows existing at the same time.
Exactly. How does this not look like a ghost image?
That is a highly astute observation, and it highlights a critical limitation of basic image blending. You are completely correct that a simple alpha blend doesn't move shadows or shift the angle of the sun.
It just changes opacity.
Merely changes opacity, exactly. But remember the context of the Catalina image. It is a massive, static landscape.
Oh, I see.
The physical geometry, the rocks, the mountains, the horizon line, none of that moves a single pixel. Only the lighting changes.
Because the camera was bolted down on a tripod for 24 hours, the pixels align perfectly.
Precisely. If there were clouds moving across the sky or waves visibly crashing on the rocks, a 67% blend would look atrocious.
You'd have ghost waves floating in the sky.
Yes, transparent ghost waves. But because the underlying geometry is completely identical, crossfading the lighting actually creates a reasonably convincing synthetic intermediary step.
Wow.
It leans heavily toward midnight, but introduces the faint, overall ambient glow of the coming dawn. And the script labels this newly generated frame as synthetish, meaning synthetic.
And then at 2 a.m., I assume it flips the ratio. So 33% midnight, 67% dawn.
Exactly. It's a mathematical crossfade, executed perfectly in a loop, handling the wraparound at 11 p.m. back to midnight.
That is so clever. But he didn't just generate the images, did he? He left a very subtle fingerprint on them.
He did. He programmed the bash script to burn a timestamp onto the bottom right corner of every symbol frame.
That sort of watermark.
Yeah, it was actually a necessary debugging step at first to make sure his logic was right, but it became a permanent aesthetic choice. He utilized the Deja Vu Sans font, setting the point size to 36 in pure white.
But wait, white text on a bright noon sky would be totally invisible.
Which is why he defined an undercolor in the script using the hex code #00000000000.
Okay, let's break that hex code down.
Sure, the first 6 characters, the zeros, dictate pure black, and the 80 at the end sets the alpha channel the opacity to 50%.
Ah, so it generates a semi-transparent dark box behind the crisp white text.
Exactly, guaranteeing legibility across all 24 hours of shifting light.
That's attention to detail. And the placement is incredibly deliberate too, right?
Yeah.
In a command line interface, you can't just drag a text box with your mouse to where it looks good.
Not at all, you're flying blind. He had to define variables. SafePadX as 150 and SafePaddy as 1380.
Just think about the tediousness of that for a second. Running the script, opening the image, realizing the text is slightly too low, adjusting the y-axis by 10 pixels, running it again.
It's painstaking work.
Yeah.
But he specifically chose 1380 to ensure the text sat perfectly above the bottom crop line for a 16.9 video format.
Which proves he wasn't just thinking about desktop wallpapers anymore. He was already architecting the framing for the final video output while he was still compiling static JPEGs.
He was definitely planning ahead.
Which, brings up a fascinating philosophical tangent for me.
Oh.
Yeah, when Steven runs this script and generates that 1 a.m. image, the 67383 blend, what exactly is that? Apple didn't capture that light. It never existed in physical reality on that island.
Right.
It only exists as an algorithm's mathematical compromise between two moments in time. Does it cease being a photograph and become pure data?
That's a great question. I'd argue it becomes a procedural simulation. You are literally forcing the computer to hallucinate the missing hours based on boundary conditions.
It's a synthetic memory of a day that never officially happened.
Beautifully put. And the crazy thing is, this was merely the prep work.
Right. We haven't even gotten to the video part yet.
He now has 24 images, a mix of authentic anchors and synthetic hallucinations sitting in a directory.
But if you just string 24 images together, you just have a time lapse that updates once a second.
Which is going to be jerky and staccato.
And he wants this to flow. He described his end goal in the project notes as wanting it to look like liquid silk.
Getting to liquid silk requires immense computational muscle. This is where most people, even professionals, would drag those 24 images into Premiere Pro or DaVinci Resolve, apply a cross-dissolve transition, and click render.
That's exactly what I would do. It's the path of least resistance.
But Steven deliberately rejected that path.
And that is the part that boggles my mind. Why on earth is he using a makefile for a video project? Makefiles are for compiling software, aren't they?
Traditionally, yes, they are. A makefile basically reads a dependency graph. You tell it program C depends on file A and file B. If file A changes, run this specific command to rebuild program C.
Right. It tracks what needs updating.
Exactly. But when you abstract that concept, video rendering is really just a massive compilation task. Steven told the makefile, my final 4K video depends on these 24 input images and this specific MP3 file.
Oh, I see. So if he notices a typo in the timestamp on image 14, he fixes that one image, types make in the terminal, and the system automatically knows exactly which parts of the video need to be re-rendered without human intervention.
You nailed it. It creates an incredibly structured, repeatable pipeline. There is zero risk of accidentally bumping the Steina timeline out of sync by a single frame because your mouse slipped.
It is pure deterministic logic.
Exactly. Now, the engine actually executing that logic within the makefile is FFmpeg.
Okay, I know FFmpeg is legendary in the developer community, but for you listening who hasn't stared at a terminal window before, how do you even describe it?
FFmpeg is basically the Swiss Army knife of digital media. It is a free, open-source command line tool that can decode, encode, transcode, mux, demux, stream, and filter virtually any video or audio format ever created by humans.
That's a serious resume.
It is, but here's the catch. It is entirely text-based. You don't get a preview window, you don't get buttons.
So no drag and drop.
None. You feed it a string of arcane text parameters, and it executes them with brutal, uncompromising efficiency.
And Steven fed it an absolute monster of a parameter string. Let's look at what he's trying to do here. He's taking 24 static frames and targeting 4K UHD resolution, that's 340 by 2060 pixels, at a buttery smooth 60 frames per second.
It's a massive upscale in complexity.
Yeah. How does FFmpeg invent 60 frames of motion per second from a handful of still pictures?
He utilized a highly advanced FFmpeg filter called minterpolate. If you look in his makefile, you see this string. Minterpolate FPS 60.mymode mci.scd none.
Okay, here's where it gets really interesting. Let's break that alphabet soup down because this is the core of the digital alchemy he performed.
Let's do it.
So FPS 60 is straightforward, frames per second. But what is MMOD-MO?
MOHP stands for Motion Compensated Interpolation.
Okay.
Earlier, we talked about why a simple 67% crossfade works for the static rocks, but fails if there's moving, like waves or clouds. MCI is the mathematical solution to movement.
How does it work?
It doesn't just fade pixels across frames. It analyzes the image, identifies micropatterns, and calculates optical flow vectors. Yeah, it mathematically predicts exactly where a pixel from the 1 a.m. frame needs to travel to become the pixel in the 2 a.m. frame, and it physically draws the intervening frames of motion.
So it's basically acting like a digital animator, drawing the in-between frames based on physics calculations.
Exactly. It's generating the missing data intelligently. And the final piece of that string, skd none, is crucial too. That disables scene change detection.
Why would he want to turn that off?
Normally, if a video algorithm detects a sudden cut between completely different shots, say from a close-up to a wide shot, it immediately stops interpolating so it doesn't create a weird, distorted morphing effect.
Oh, like melting faces between cuts.
Right, which looks awful. But Steven forced the algorithm to interpret the entire 24-hour cycle as a single, unbroken, continuous camera shot. He deliberately blinded the safety rails so it wouldn't stop interpolating when the lighting shifted significantly.
The scale of what that command does is just staggering.
Yeah.
We go from 24 source images to 7,203 individual, uniquely calculated frames of 4K video.
It's a monumental amount of math.
But this is where the physical reality of hardware crashes into the elegance of code, isn't it? Because rendering 7,200 frames of motion-compensated matrix math on a standard computer CPU is agonizing.
It brings systems to their absolute knees. When you rely on a CPU instead of dedicated GPU hardware for this level of vector calculation, progress bars crawl at a fraction of real-time speed.
I can only imagine.
You might hit enter on that FFmpeg command and have to wait 6 hours just to see if you made a typo.
Exactly. If you realize the audio fade is off by half a second, you just burned an entire afternoon waiting for a useless render.
Which is incredibly demoralizing.
But this is where Steven showcased incredible engineering maturity. Instead of just brute forcing the render and praying, he built microenvironments. He created test targets in the make file called 4K short and 1080p short.
I loved seeing this in the source files. These targets were programmed to run the entire complex FFmpeg pipeline, but only output a 24-second preview loop instead of the full multi-minute video.
He built a microcosm of a 24-hour cycle inside a 24-second test tube. That is such a smart way to iterate.
It saved so much time. It allowed him to quickly verify his crop logic because the original Apple images weren't perfectly 16.9, meaning they had to be dynamically scaled and cropped without stretching.
Okay.
And crucially, it let him test the audio engineering without waiting hours.
And we should talk about the audio, because audio engineering in FFmpeg is notoriously difficult.
Because you are mixing sound blindly. You cannot see a waveform like you can in Pro Tools or Audition.
Right. Steven wanted a moody, atmospheric soundtrack to accompany the shifting landscape. He selected a track titled Telling Story by DJby.mp3, but he needed the music to fade out perfectly in sync with the end of the video loop.
The video loop is exactly 120.047 seconds long, so he calculates the fade mathematically.
In his head.
Basically. In the make file, he defines a variable fade start as 117.047 seconds. Then he applies the FFmpeg filter fadetout.st 117.047.d3.
Which means fade out, starting precisely at 117.047 seconds, with a duration of exactly 3 seconds.
That's like conducting a symphony using a spreadsheet.
It really is. It's a flawless systems thinking approach. Isolate the variables, test them in a controlled, low computational environment, verify the math, and only then commit the CPU to the massive final production load.
But let's be honest about what it takes to write a string like 0.vscale 3840.2160 that force original aspect ratio increase, crop 3840.2160.
Yeah, that looks like complete gibberish to most people.
Memorizing that syntax is unreasonable for someone who isn't doing this full time, and Steven didn't do this alone in the dark.
Which brings us to the next big piece of this puzzle. This project is a phenomenal case study in modern workflow because of his ultimate collaborator, Google Gemini.
Yes. This completely reframes the narrative of how AI is actually being used by professionals right now.
It's not just a toy.
Exactly.
Yeah.
Gemini wasn't given a lazy prompt like, make a 4K video out of these pictures. AI wasn't the creator here. Steven had the vision. Gemini acted as a translation layer.
I love that framing. It bridged the gap between human intent and archaic terminal syntax.
Right. I can imagine Steven knowing exactly what he wants. I need to scale these up, crop the center, interpolate the frames to 60ps, and fade the audio at the very end. But wrestling with where to put the semicolons versus the commas in FFmpeg.
Because one misplaced bracket and the whole pipeline crashes?
It does. Gemini handles the syntax so the human can focus on the architecture. It also debugged the makefile.
Oh, that is huge.
Anyone who has ever written a makefile knows the unique agony of an entire build failing because you used spaces instead of tabs for indentation.
It's infuriating.
Having an AI copilot instantly spot a rogue space character saves hours of profound frustration.
But it didn't just help with the code, did it? It also acted as a creative sounding board.
It did. The project notes showed Gemini helped brainstorm the narrative flow of the documentation. It even generated the highly optimized YouTube title, Apple's iconic Catalina wallpaper brought to life in 4K 60 FPS.
That's a great title. Highly clickable.
Very. It demonstrates that AI, in this context, lowers the barrier to entry for highly technical execution without removing the human's creative agency.
If you've ever felt overwhelmed by learning a new coding language or tool, this is your blueprint. You no longer need to be a 20-year veteran of Linux system administration to build something this complex, provided you know how to clearly communicate your intent to an LLM.
Exactly. Steven used AI as a technical sounding board to amplify his own human curiosity.
So curiosity meets code, the AI polishes the syntax, the 24-second test loops look flawless, and Steven finally hits enter on the big one.
The final render.
The CPU grinds away probably for hours, and out pops the masterpiece. 7,203 frames of liquid silk.
It must have been such a satisfying moment.
Oh, totally. A fully immersive, 24-hour time-lapse of a rugged island, smoothly transitioning through starry nights and golden sunrises, all reverse-engineered from a single Apple system file.
A huge open source victory.
So he uploads it to YouTube, ready to share this incredible triumph with the world,
Yeah.
and then reality hits him like a freight train.
The epilogue of this project is a brutal collision between grassroots, artisanal engineering, and the reality of the modern corporate internet.
It is so painfully ironic. Literally, the second the upload finishes processing, YouTube's automated content ID system flags the video with a copyright claim.
Unbelievable.
After hours of meticulous frame-by-frame mathematical blending to avoid jarring visual shifts, his project is instantly snared in a mindless automated dragnet.
The irony is rich. What did they even claim? Did Apple unleash their legal team because he extracted a proprietary HEIC file?
No, that's the craziest part. Apple didn't care. The claim was for the audio track.
Oh.
The melody and lyrics of a song called The Night, claimed by entities listed as UMPI CD Baby Sync Publishing.
Which is utterly absurd given Steven's own documentation. He specifically noted that he used an obscure MP3 by someone he refers to as the infamous DJ Die.
Right, the file in his directory is literally named Telling Story by DJ By.mp3. Steven writes in his notes that this DJ By is nowhere to be found to be given credits to.
So he tried to do his due diligence.
He tried to do the right thing, couldn't find the guy, used the track anyway because it fit the moody vibe perfectly, and is immediately ambushed by a phantom publishing conglomerate.
Automated copyright dragnets, like Content ID, don't possess nuance. They match waveforms against massive databases.
Right.
If a massive publishing entity buys up the rights to obscure beats, or if an algorithm falsely matches a generic synth pad, the creator is instantly penalized.
And Steven's unfiltered reaction in his project notes is perhaps the most relatable moment of the entire deep dive.
What did he write?
He simply writes, "Who the F is CD Baby Sync Publishing?"
That is hilarious. And so true. It is the ultimate modern creator's dilemma.
It really is. You can master Linux, you can build makefiles, you can wield FFmpeg like a sorcerer, and partner with cutting-edge AI to execute flawless command-line automation.
You can democratize the tools of Hollywood-level production from your literal garage.
But the moment you try to share it, you are completely at the mercy of opaque algorithms and untraceable bots on platforms that don't care about your workflow.
It exposes a massive friction point in the creator economy. The tools of creation are entirely open and democratized now, but the avenues of distribution are increasingly locked down, automated, and policed by systems designed to protect corporate IP at the expense of independent creators.
Now, to be fair to the platform, the claim didn't result in a strike, right? The video wasn't taken down.
True. It simply inserts a third-party corporate entity into the monetization and ownership dynamic of a deeply personal, passion-driven project.
Still, it's a jarring juxtaposition. The painstaking math-driven care Steven put into calculating optical flow vectors and timestamp pixel offsets, completely derailed by the blunt, thoughtless mechanism of a music copyright suite.
It's frustrating, but if we pull back from the YouTube drama, what does this entire project represent for you, the listener?
So what does this all mean?
It proves that we are living in a golden era for the curious tinkerer. The technical barrier to entry has essentially evaporated.
It has. If you have an idea, even a weird, highly specific obsession with a desktop wallpaper, you have an AI co-pilot ready to translate your vision into executable code.
You just have to be willing to open the terminal and start talking to the machine. Steven's journey from a static.heic file to a 4K 60 FPS cinematic loop is a testament to the power of pure persistence augmented by the right tools.
Which leaves me thinking about where this technology is inevitably heading. Steven used FFmpeg to mathematically hallucinate the hours between 1 a.m. and 3 a.m. He forced a computer to dream up the missing moments of a day.
Right.
But as generative AI models become incredibly sophisticated, capable of rendering video in real time.
Oh, I see where you're going with this.
Right now, operating systems rely on anchor images. An artist has to take a photo or render a 3D scene for your computer to display. But if algorithms can already perfectly interpolate movement and shifting light based on simple prompts, how long until the concept of a static wallpaper file is entirely obsolete?
That is a wild thought.
What happens when your operating system doesn't load a picture, but instead actively hallucinates your desktop environment in real time, subtly changing the weather, the lighting, and the scenery based on your workflow, your stress levels, or the actual weather outside your window?
Through tools like FFmpeg's Interpolate, Steven was doing this manually. But when we artificially fill in the blank spaces of a digital record in real time, are we preserving time, or are we fabricating a completely new reality that never actually existed?
So we aren't just thawing out the digital fossil. We're moving toward a future where the fossil never exists in the first place. Your digital environment becomes a completely fluid, generative hallucination that lives and dies in the moment you look at it.
It's something to chew on the next time your screen subtly shifts from afternoon to evening.